5 into 10 power 1 plus 6 into 10 power 0. 10 power 0 is 1 only. So when you do this, you get 3256. This number is in decimal. Okay. From the above example, we can see that the weight of the nth digit of the number from right hand side is equal to the nth digit into 10 power n minus 1, which is again equal to nth digit. Okay, base to the power n minus 1. Okay. So here, see, this is the first number. Okay, Z6 is the right from right hand. 0, 1, 2, 3, like that you should take. That's why we have multiplied 3 into 10 cube. See, okay, 0 is in the 6 is in the 0th position. 0, 1, 2, 3. Okay, so here, so when you multiply that 3 into 10 cube plus 2 into 10 square plus 5 into 10 power 1 plus 6 into 10 power 0, you get 3256. 10 cube means how much? 1000 into 3 means 3000 plus 10 square is how much? 100. 100 into 2, 200 plus 5 into 10 power 1, 10 power 1 is 10 only. So 5 into 10 is 50 plus 6 into 10 power 0 is 1. See, if you don't understand, don't worry. This requires lot of mathematical knowledge. Okay, 10 power 0, those 6 into 10, 6 into 1 is 6. So that is what we are getting. Okay. So this is the how we do, that is base to the power n minus 1. 1, 2, 3, 4. Means this is the base. Base to the power n minus 1 means 1, 2, 3, 4. 4 minus 1 how much? 3. Okay. So 0, 1, 2, 3. Okay, the number system in which the weight of each digit depends on its relative position within the numbers is called as the positional number system. For this, we call it as a positional number system. It starts from 1, 2, 3, 4. There are 4 numbers now. 4 minus 1 is how much? 3. So, this is called positional number system. Next is binary. Binary number system. The base or radix of the binary number system is 2. See, for decimal, the base, you just remember, decimal number system uses the base is 10 here. Radix is base or radix. This is decimal. For decimal, it is 10. You just understand that for decimal number system, the base or a radix is 10. Okay. If you don't understand this calculation, don't worry. Okay. So next is binary number system. Binary number system, the base or radix is 2. You just remember, for binary, the base or radix is 2. In NET exams also, they'll ask a base or the radix. Okay. You just know only this one. Okay. It uses only two digits, 0 and 1. Binary means it is either 0 or 1. So data is represented in a computer system either by presence or absence of electronic or magnetic signals in its circuitry or the media it uses. This is called as a binary. Binary, I told you in the last class only. It is either 0 or 1. Okay, computer understands only 0 or 1 or two-state representation of data. Since the computer is indicating only two possible states or conditions, on or off. Okay, for example, transistors and other semiconductor circuits are either in a conducting or non-conducting state. Media such as magnetic disks and tapes indicate the two states by having magnetized spots whose magnetic fields can have two different directions or polarities. It is either on or off. Okay. So here you can see decimal number, binary, decimal binary. See how you can convert 0 to 0. In decimal, if it is 0, it is 0 only. If it is 1, 1 only. 2, 1, 0. So how it is converted? It has to be divided. That conversion and all, you don't worry, because it requires so many classes to explain that. Okay, you have to divide by 2 to get 1, 0. If you divide by 2, this decimal number, you get 1, 0. 3 is 1, 1. So next is binary to decimal. How to convert binary to decimal? Okay. So here the weight of nth bit of a number from the right hand side is equal to nth bit into 2 power n minus 1. See how we have calculated, it is given here. Okay, so here now the binary number, now for example, the binary number, how to convert from binary to decimal. For example, 1001 is equal to, this is a binary number. How to get that binary number? You need to, or you have to divide by 2 continuously. Decimal number divide by 2 continuously, and then whatever the remainder you get, that is what this. Okay, this binary. This is converted by dividing the decimal number by 2. You get like this. Okay. So these are all the reminders. For 1 it is 1. For 2 it is 10. For 3 it is 11. For 4 it is 100. Okay. So this is what the. So this 1001, this 1001 is the decimal 9. Okay, you can see here 9. So this is how it is converted. Okay, so 0, 0, 1, 2. Okay, 0, 1, 2, 3, like that it will take. Okay, so here 2 to the power of 0, 1 into 2 power 0, 2 into 2 power. So 0, here this is 1. Okay, they have taken 1 into 2 power 0. Then 0 into 2 power, so 1 into 2 power 0. So again 0 into 2 power 1. Then 1 into 2 power 2 means 0, 1, 2, 3, like that. Okay, so here it is 0, 1, 2, 3. Okay, so when you multiply that, you get, this is actually wrong. This is 3. Here it should be 3. See, 0, 1, 2, 3. So 1 in 1 cube. Okay, so 1 cube it is equal to 2, 4, 5, 6, 7, 8 it will come. 2 cube is 2 into 2 is 4. 4 into 2 is 8. Okay, so here this is not 4. It is 8 plus 1. So this is wrong. This is 8. This is 8 and this is 1. So this is equal to 9. Okay. So this is the mistake. 0, 1, 0, 1, 2, 3. 1 into 2 cube. 1 into 2 cube. 0 into 2 square. Something multiplied by 0 is 0 only. One more 0 they have missed. Okay. 1 plus 0 into 0 multiplied by something is 0. So here it is 9. Okay, got it. So here like that, 1 0 1 0. This is the binary number. 10 is the decimal number. How we are conducting? The right hand side is 0 1 2 3. So 0 into 2 per 0 is something multiplied by 0 is 0. 1 into 2 power 1, 0. So it is 10. Okay. So if you don't understand, don't worry. Just know that binary conversion of binary is from, this is what we convert. Okay. Next is decimal to binary. So how you convert from decimal to binary? Okay. 14 we have given. So divide by 2 till you get the remainder 0. So you have to read it like this, from bottom to up. 1 1 1 0. This is the 1110 is the equivalent of 14. So this is the binary. 1110 is the binary form of decimal 14. Okay. So if you don't understand it, don't worry. Just know the base and all. 9's complement, 10's complement, it's not there for you. So octal. Octal means 8. Okay, you should know octal. Now we'll learn octal number system. Octal number system refers to the base 8 or radix 8, 0 to 7. Okay, so here it is grouped into 3. See, binary number 000. So it is grouped into 3. So when it is grouped into 3 is 0001, it is 1. Okay, so the base is 8. Just know. So when you want to convert that octal to, when you want to convert octal to binary, octal to binary decimal, you can do like this. Divide by 8 only. So that ulta you have to read. Okay. So the number 888 is converted into octal system is like this, 1570. So when we want to convert it, divide by the respective base. Next is hexadecimal. Hexadecimal means you will know hexadecimal, 16. The base or radix is 16. So here the number system consists of 16 unique symbols, 0 to 9. Okay, 0 to 9 is 10 numbers, aitalva. So here see decimal number is 0 to 9, same binary. But in hexadecimal, 10 becomes A, 11 becomes B, 12 becomes C, 13 becomes D, 14 becomes E, 15 becomes F. Okay, so like that you should know. So here if you want to convert from hexadecimal in decimal means you have to multiply by 16. Okay, 0, 1 like that. Okay, so if you want to convert the decimal to the hexadecimal, divide by 16. You have to divide or multiply by the respective base. Okay, so next is non-weighted code. You have ASCII and EBCDIC. Okay, ASCII means American Standard Coded Information. Okay, so this XS3 code is not there for you. Okay, ASCII means Americans ASCII. They'll ask the expansion of ASCII code. ASCII means American Standard Code for Information Interchange. Okay, so here is used extensively in small computers, peripheral instruments, and communication devices. Okay, what they'll ask in asking exam says how much is that characters. Character length is 256 characters you can represent. Okay, EBCDIC code means what? Only the expansion you know. EBCDIC code is extended extended BCD means binary coded decimal interchange code. Okay, E means extended, B means binary, C means coded, D means decimal, I means interchange, C means code. Okay, now you know the expansion. That's it. Next is we'll learn classification of software. See, the software, I told you, software is classified into a system software and application software. Okay, see here, computer hardware means you know all the physical parts of a computer where you can touch and feel. For example, keyboard, monitor, computer, hard disk drive, etc. They are all hardware. Software means it is a set of instructions given to a computer, means it is a program. Okay, so this software is usually written in high level programming languages that are easier and more efficient for humans to use than machine language. You know, I told you machine language means it is a low level language. The programming is very tough in low level language because it involves only zeros and ones. High level languages are just like English like language. For example, Java, Fortran, COBOL. Anyone programmers, it is easy for programmers to write a program. Okay, so here high level languages are, computer doesn't understand high level languages. So these high level languages are compiled or interpreted into a machine language, object code. See, high level languages, whatever the languages, whichever the program you are using, a computer doesn't understand. It has to be compiled and converted into low level language, that is nothing but machine understandable language. So that language is called as the, so when it is converted, that becomes the object code. Software may also be written in an assembly language, essentially a mnemonic representation of a machine language using a natural language alphabet. Okay, so software may also be written in assembly language. Assembly language is very tough, that is tough, but compared to low level language, it is okay. Assembly languages are written in mnemonics. Some codes are there. Okay, the programmer should know the mnemonics. So here, as you are aware, computer cannot do anything on its own. Okay, so it needs a software. It is the user who instructs computer what to do, how to do, and when to do. Okay, in order to perform any task, you have to give a set of instructions in a particular sequence to the computer. These sets of instructions are called programs. It is nothing but a set of instructions which is written in high level languages, as I told you, Java, Pascal, COBOL, Oracle, etc. So software refers to a set of programs that makes the hardware perform a particular set of tasks in particular order. Software can be classified mainly into following categories and subcategories as shown in this figure. Okay, so here computer software is divided into two types: system software and application software. System software is further classified into operating system and language processor. This language processor is further translated into assembler, interpreter, and compiler. Okay, so now first we will learn system software. What is this system software? Okay, so now you know system software means when you switch on the computer, the programs stored in ROM are executed, which activates different units of your computer and makes it ready for you to work on it. This set of programs can be called system software. Okay, when you switch on the computer, you can see now Windows XP, Windows Vista. So that is your system software. System software is sets of programs responsible for running the computer, controlling various operations of computer systems, and management of computer resources. When you switch on your computer, the operating system is gets activated. So when this OS, this is nothing but your operating system. So when the user gives the commands, the rest of the components connected to the system, it works. Okay, so for example, keyboard, monitor, disk drive, printer, whatever you have connected to your computer will be able to function. Okay, so which manages and maintains disk file systems and supports application programs. Some popular operating systems are Unix, Windows, and Linux. Okay, now you are using Windows. So we will learn about Unix, Linux after this. Okay, so all those, so these are different types of operating systems: Unix, Windows, DOS. DOS means disk operating system, Linux. Unix and Linux are multi-user operating systems, whereas DOS is a single operating system, means single user. Although operating system provides all the features users need to use and maintain their systems, inevitably they will still do not meet everyone's expectations. This has led to another type of system software called utilities. These are programs that bridge the gap between the functionality of an OS and needs of users. Utility programs are a broad category of software such as compress, means zip files, uncompress, unzip files, antivirus software, split and join files software, etc. So they are all utility programs. Next is application program. I told you application software is a set of programs which are written to perform specific tasks. For example, an application package for managing library known as library information system is used to manage information of libraries such as keeping book details, account holder details, book issue details, book return details, etc. Another application package for managing student details is called Students Information System. Manages students' roll number, name, parents' name, address, class, section, etc. Application software can be broadly classified into generalized packages and customized packages. See, I told you generalized means one software which is designed can be used for many purposes. Customized package only for particular task. Okay. So the name only tells application. There are two types of application softwares: generalized and customized, or you can say specific software. Generalized packages are, these are user-friendly software written to cater to users' very general needs, such as preparing documents, drawing pictures, database to manage data or information, preparing presentation, play games, etc. For this, Word, Excel, PowerPoint, they are the MS Office, Word, Excel, PowerPoint, they are all generalized package. You can use that for many purposes. Okay, now hope you have understood that. It is a group of programs that provide general purpose tools to solve specific problems. Some of the generalized packages are listed below. Okay, I told you Word, Excel, PowerPoint, spreadsheets, presentations, PowerPoint, MS PowerPoint, Oracle, DBMS, MS Access, MS SQL, then graphic tools, Paint, Shop, Adobe Photoshop. These are all general types of, these are all general types of softwares. Okay. Customized packages means designed for specialized purpose. So these are applications that are customized. Customized means according to the user's needs or developed to meet the specific requirements of an organization or institution. For example, you can use Tally. Tally software can be used only for calculating the payroll. Okay, it cannot be used for typing a letter or creating a document, all that. Okay, so they are all specific, means specialized softwares. So these packages are developed using high level computer languages. Now we will learn what is utility programs. See, these utility programs means which help manage, maintain and control computer resources. Okay, see, these programs are available to help you with the day-to-day course associated with personal computing and to keep your system running at peak performances. For example, virus scan, backup software, scan disk, disk defragmenter. Suppose if you have, so these are all to make your computer more efficient. Okay, backup software, virus scanning. Suppose if you have a virus in your computer, it automatically detects and scans and it tells you. Okay, backup software means to take the backup of your data. Scan disk to scan for anything you have virus. Then disk defragmenter means it collects all the data in one by one only. Okay, so your data is arranged in a segmented format, so it will make it segment in a all desegmented fragments are converted into single fragments. Okay, so this virus scanning software means what? You already know there are so many antivirus softwares are there. So virus scanning software are utility programs designed to protect your computer from computer viruses. Okay, they are antivirus. Virus scanning software is critical to use. Due to the number of computer viruses, small programs created to disrupt and destroy computer files and operating systems. See, what is this virus means? A small program. Unknown program gets multiplied, okay, by itself. So that becomes the virus. So here, virus scan software scans your disk each time when you insert it into a computer uh, at an whatever the when you start the computer, when you insert any secondary storage devices at that time, it asks you for why it immediately, if there is any virus, it gives the message. If you receive a warning that there is a virus suspected on your disk, contact the lab assistant to help you eliminate the virus. Means as per the antivirus software, you can remove if you want, otherwise you can skip. It is better to scan then and there and remove the virus. Okay, next is backup software. What is this backup software? This backup software is a software that assists you in backing up your files and even the entire computer hard drive. Okay, backing up is required, otherwise you will lose data if your system gets corrupted, or if there and the loss of power and all. Okay, so you should think about how to back up your valuable data on your hard drive. So the server that houses your home folder is backed up regularly. Okay, so really you have a option there, so you can select that automatically. The backup software, it takes the backup of your entire hard disk. Then what is this scan disk? Scan disk is a utility provided with Windows computers. Scan disk scans your disk to see if there are any potential problems on the disk, such as bad disk areas. Since disks are magnetic media, all disks, including your hard drive, can be corrected. So this is the utility scan disk. It's automatically is available in your OS. Next is disk defragmenter software. This assists you in keeping reorganize your disk drives. After files are saved, deleted, and resaved again, the disk can become fragmented. Available space in the small blocks located throughout the disk. Disk defragmenters gather those free spots and put them together to enable you to continue to save your data in the most efficient manner. See, in the disk you have a memory, continuous memory like this. Okay, when you write a program, some part is stored here. When you delete this part, so this much of space is vacated here. So when you these spaces are removed and it is stored continuously like this. Okay, so it is called as defragmenter, means it collects all the data one by one. Okay, so that it space your, see, that is what it is saying. This fragmenter gathers free spots and put them together to enable you to continue to save your data in the most efficient manner. Okay, now you know hardware means what, you know software means what, you know how softwares are classified. Okay, now we will learn language translators and programming languages. So here types of programming languages. So there are in all over the world, language is the source of communication among human beings. See, if you, how you are communicating with your friends, you are communicating with a common language. In Karnataka, you use Kannada. If who is outside from Karnataka, you are using a language called English to communicate with other state people. Okay, so that is what the language we use for communication. Like that only, in computers we use the languages in order to communicate between the user and the machines. Okay, so here different countries, different regions have different languages. Similarly, in order to communicate with the computer, user also needs to have a language that should be understood by the computer. Okay, for this purpose, different languages are developed for performing different types of work on the computer. Basically, languages are divided into two categories according to their interpretation. Okay, see how I told you low level language and high level language. I have already explained you what is low level languages, what is high level languages. Okay, in short, low level computer languages are machine codes or close to it. Computer cannot understand instructions given in high level languages or in English. All high level languages are written in English like language. Okay, it can only understand and execute instructions given in the form of machine language. I told you what is machine language, which is written in the form of zeros and ones. There are two types of low level languages. One is machine language. Machine language, zeros and ones. The other one is assembly language. In assembly language, program is written in the form of mnemonics. Okay, they are low level languages. So again, these mnemonics is getting, it has to be converted into zeros and ones. Machine language need not. Okay, so now we will learn. So what is machine language? Machine language, it is the lowest and most elementary level of programming language and was the first type of programming language to be developed. Okay, machine language is basically the only language which computer can understand. In fact, a manufacturer designs a computer to obey just one language. It's machine code, which is represented inside the computer by a string of binary digits, zeros and ones. As I told you, since the first class I have been telling you, computer doesn't understand anything. Whatever you feed to the computer has to be get converted into zeros and ones. So it is called as digital. Okay. The symbol 0 stands for the absence or off. Okay, off of electric pulse, and 1 for the presence of an electric pulse. 0 means off, 1 means on of electric pulses. Since a computer is capable of recognizing electric signals, therefore it understands machine language. Okay, computer understands only machine language. Advantages of machine language is it makes fast and efficient use of the computer. It requires no translator to translate the code that is directly understood by the computer. Only these two are the advantages. Let us study the disadvantages of machine language. All operation codes have to be remembered. It's very, very difficult. Writing, imagine writing in the form of zeros and ones. It's a very, very lengthy process. It is more prone to errors. Okay. So all memory addresses have to be remembered. It is hard to amend or find errors in a program written in the machine language. It is a machine dependent. That is, a particular machine language can be used only on one type of computer. It's very, very tough. Next, we'll study assembly language is also a low-level language. Okay, it was developed to overcome some of the many inconveniences of machine language. This is another low-level but a very important language in which operation codes and operands are given in the form of alphanumeric symbols instead of zeros and ones. So here, alphanumeric symbols means it assembly language has got a mnemonics, means there is a set of codes that you have to remember. So when you compare to machine language, this is at least comfortable to write. Okay, but this is also very tough. So when you compare to machine language, assembly language is okay. So these alphanumeric symbols you have to remember while writing the program. So these alphanumeric symbols will be known as numeric mnemonic, mnemonic codes, and can have maximum up to 5 letter combinations. For example, ADD for addition, SUB for subtraction, then START, start, label, etc. Means when you start, you have to give label. Label means to which line it is linked, etc. So you have to remember all this. Because of this feature, it is also known as symbolic programming language. See, you should remember, assembly language is also known as symbolic programming language. They will ask you in NET like this, assembly language, whether it is a high level language or low level language, they'll ask. Then what you will say? It is a low level language. Assembly language is also called as a symbolic programming language. Only these two you try to remember. This language is also very difficult and needs a lot of practice to master it because very small. So here you need to remember each and every coding in this. Okay, English support is given to this language. The language mainly helps in compiler orientations. So here, the instructions of assembly language will also be converted to machine codes by language translator to be executed by the computer. See, the program written in assembly language, computer doesn't understand. So it has to be converted into a machine language. How it is converted? By a language translators. Okay, what is that language translators? I will explain. Okay, so there are translators, whatever you write in high level languages or assembly level language, it has to be converted into machine language or low level language. So the translator is called as a language translator. We'll learn later. Okay, next is advantages of assembly language. What are the advantages? When you compare to machine language, it is easier to understand and use as a compared to machine language, because it is easy to understand when you compare to machine language. It is easy to locate and correct errors. Here it is simpler and you can correct errors, but in the machine language it is very difficult. It can be modified easily. We can, suppose if you find any errors, you can modify if you know the set of instructions how to write a program in mnemonics. Okay. Next is disadvantages of assembly language. Like machine language, it is also a machine dependent. Since it is a machine dependent, therefore programmer should have the knowledge of the hardware also, what the hardware it contains. Next is high level languages. As I have been telling you, which are all languages which have been written in English like languages, they are all high level languages. High level computer languages give formats close to English like language. And the purpose of developing high languages is to enable people to write programs easily and in their own native language environment. Okay. High level languages are basically symbolic languages that use English words or mathematical symbols rather than mnemonic codes. Instead of using mnemonic codes, just like English like language, they will write a program. Okay, each instruction in the high level language is translated into many machine language instructions, thus showing one to many translation. So types of high level languages. So I have been telling you different types of high level languages. Now you are already familiar with that. So many languages have been developed for achieving different variety of tasks. Some are fairly specialized, others are quite general purpose. So these are characterized according to their use as algebraic formula type processing. These languages are oriented towards the computational procedures for solving mathematical and statistical problem. Examples are basic. I told you basic means it's a first English high level program means see they will ask in NET basic expansion beginners all purpose symbolic instruction code. Fortran means formula translation. PLI means programming language version. Okay, PLI version 1, 2 like that. Algol means algorithmic language. PLI means a programming language. APL means a programming language. Okay. Next is so you have like that you have Java, Oracle, Fox Pro, etc. Now many are there. They are all what high level languages. Next is business data processing. These languages emphasize their capabilities for maintaining data processing procedures and file handling problems. Examples are COBOL. COBOL is used for business purpose, common business oriented language. See, this also they had asked in NET, COBOL expansion. COBOL business oriented language. Right? And RPG means report program generator. Okay. So, next is string and list processing. These are used for string manipulation, including for pattern search, including search for patterns, then inserting and deleting characters. Examples are list processing and list means list processing and prolong. Computer in logic. What's I'll call you later. Okay, so next is program in logic, object-oriented programming language. Okay, OOP we call it as OOP means in OOP object-oriented programming language. Java is an object-oriented programming language. In OOP means object-oriented programming. The computer program is divided into objects. Examples are C++ and Java. Visual programming language. These are designed for building Windows-based applications. Examples are Visual Basic, Visual Java, Visual CC. These are all different types of high-level languages. Okay, Java, Oracle. Oracle is a database software. So advantages of then you have web designing software, PHP, then HTML, DHTML, they are all high-level languages only. So here, advantages of high-level languages are they are very user-friendly, similar to English with vocabulary of words and symbols. Therefore, it is easier to learn. See, now you are using Word, Excel, PowerPoint. All these applications are written in C language, any high-level language, C language, C or C++. You are using it because high-level language is user-friendly. See how nicely you are using Word, Excel, PowerPoint, right? Computer doesn't know all this, but everything is converted into machine language, like zeros and ones. It is user friendly. You can write, you can type up whole document, you can do editing, you can modify the text, you can draw some figures, you can do so many editing, modification, everything, because it is so easy. But computer doesn't understand all this, so they require less time to write. They are easy to maintain, problem oriented rather than machine based. Program written in high level languages can be translated into any machine language and therefore can run on any computer for which there exists an appropriate translator. See, for all this, whatever the program you write has to be converted into zeros and ones. In order to convert this high level language into machine language, we have a language translator that we will learn. So which are the language translators? Compiler, interpreter, and assemblers. These three are the translators. They do wonderful work. Okay, so only we feel computer is very easy to operate, but it's not so easy inside the computer. Okay, all these beautiful things are done by these language translators. It is independent of the machine on which it is used. That is, programs developed in high-level language can be run on any computer. Disadvantages of high-level language. A high-level language has to be translated into machine language by a translator, and thus a price in computer is paid. Okay, the object code generated by a translator might be inefficient compared to an equivalent assembly language program. Next is language translators. Now you have learned what is low-level language, what is high-level language. See, the low-level language, machine language, doesn't need any translators. It is directly converted. It is directly written in zeros and ones. But for the high-level language, I told you it has to be converted into a machine language. So a program is a set of instructions for performing a particular task. These instructions are just like English words. The computer interprets the instructions as ones and zeros. A program can be written in assembly language as well as in high-level language. This written program is called as the source program. Whatever the program written in high-level language, it is called as a source program. Computer doesn't understand source program. So this source program has to be converted into machine understandable language called as object program. Okay, a translator is required for such a translation. Program translator translates source code of programming language into machine instruction code. Generally, computer programs are written in languages like C, COBOL, C, Pascal. These are all high-level languages which should be translated into machine language before execution. So different types of translators are assemblers, compilers, interpreters. Now we will learn what assemblers, compilers, and interpreters individually. Okay. So assembler is what? Assembler is a translator which is required to convert the program written in source program written in assembly language into machine language. Okay. A computer will not understand any program written in a language other than its machine language. The programs written in other languages must be translated into machine language. Such translation is performed with the help of a software. A program which translates an assembly language program into a machine language program is called as an assembler. Got it? Assembler means which converts an assembly language program into machine language program is called an assembler. Only assemblers can translate the mnemonic codes. If an assembler which runs on a computer and produces the machine code for the same computer, then it is called a self-assembler or resident assembler. Okay. If an assembler that runs on a computer and produces the machine codes for other computer, then it is called as a cross-assembler. Nowadays, all operating systems have assembler, compiler, interpreters built in. Okay. So you don't need cross-assemblers most of the time. So assemblers are further divided into two types. One-pass assembler and two-pass assemblers. What is one-pass assembler? One-pass assembler is the assembler which assigns the memory addresses to the variables and translates the source code into machine code in the first pass simultaneously. Okay. In one-pass assembler, the assembler which assigns the memory address to the variables and translators to the variables, it translates that source code into a machine code in case of first pass. Whereas in second pass assembler, the assembler reads the source code twice. In the first pass, it reads all the variables and assigns them memory addresses. In the second pass, it reads the source code and translates the code into object code. See this diagram. See, this is the source code, means a program written in assembly language, which consists of mnemonics. Okay. So here assembler, this translates that into executable code. So this assembler does in two passes. Pass one, it identifies, then it assigns the memory locations. In the second pass, all the variables, all the programs stored in the memory locations gets converted into low level language, that is machine language executable code. Okay. So that is what. Next is you have a different type of that is the language compiler. Next is compiler. Compiler, it is a program which translates high level language program into machine language program. A compiler is more intelligent than an assembler. It checks all kinds of limits, ranges, errors, etc. But its program runtime is more and occupies a large part of the memory. It has slow speed because a compiler goes through the entire program and then translates the entire program into machine codes. If a compiler runs on a computer and produces the machine code for the same computer, then it is known as a self-compiler or resident compiler if it is on the same computer. Now, nowadays, all operating system, OS is inbuilt only. Compiler, interpreters, assemblers, it is there in the OS. On the other hand, if a compiler runs on a computer and produces the machine code for other computers, then it is known as a cross compiler. The name only tells now you are converting for other computers, so it is called as cross compiler. See the diagram. Source code, compiler, source code is getting converted by this compiler. Compiler converts the whole program into executable code. See, the compiler, beauty of the compiler is it reads the entire source program fully, then it converts to executable form. Okay. There is a same procedure for interpreter also. Now I will tell you what is the difference between a compiler and an interpreter. An interpreter is a program which translates statements of a program into a machine code. Okay. It also translates from high to low, but here it translates one statement of the program at a time. So what you read in compiler, the whole entire program it will read once and then it will convert into a executable form. Okay. Object code, executable code. But here in interpreter there is a slight difference. This reads each line by line. It reads first line, then it converts, then it goes to the second line of the program, then it converts. Okay. So it reads only one statement of a program at a time and translates it and executes it. Then it reads the next statement of the program, again translates it and executes it. Okay, line by line. as shown in the, this is the figure. Okay, line by line it reads. Okay, on the other hand, a compiler goes through the entire program and then translates the entire program into a machine code. A compiler is 5 to 25 times faster than an interpreter. By the compiler, the machine codes are saved permanently for future references. On the other hand, the machine codes produced by the interpreter are not saved. That is the difference. An interpreter is a small program as compared to compiler. It occupies less memory space, so it can be used in smaller system which has limited memory space. See here, this is a source program, this is an interpreter, this is an executable code. Again, next instruction. Now get one more instruction. After executing the first line, again it will come, get next instruction. It will go to the source code. Means, see, like this. So first it will read this line. Okay, then this interpreter will convert into executable code. Then it is saying that get instruction, means it will go to the, now this is the second line. It will go to second line, it will fetch second line, it will convert into executable code. So like this, one by one. So this is the loop. So this is the difference. Hope you have understood the difference between assembler, compiler and interpreter. Now tell me, students, what do you mean by an assembler? Assembler is a low level language. Okay, you have learned low level language and high level language. Low level language means machine language and assembly language. Machine languages are directly written in the form of zeros and ones, whereas assembly language programs are written in the assembly language by using mnemonic codes. Okay, so computer doesn't understand assembly language. So in order to convert that, assemblers are used to convert assembly language to machine language. Whereas compiler and interpreters both are the language translators. It translates into low level language, but how? There is a slight difference. Compiler, it reads the whole program, entire program at once, then converts. Okay, you can see this diagram. The whole program, it compiles and then it gives the executable code. Whereas interpreter reads line by line. First line it reads, it converts into executable code. Then it goes to second line, it converts into executable code. So that is the difference. Compiler is much faster than interpreter. Hope you have understood, students. So we have learnt compiler, language processors, machine language, low level language, all that you have learned. Now we'll move to operating system. What do you mean by an operating system? And there are different types of operating systems. So here operating system means operating system means what? It coordinates between the user and the computer. Any computer, for example, whatever the computer take, it should have a OS. OS means operating system. Any computer system you use should have an operating system. The user interacts with the machine via the operating system. Now, when you want to use your computer, you need a OS. OS means Windows XP. When you start your switch on your computer, it displays Windows Vista, Windows XP, like that, Windows 10. So even when you use your mobile phones, some are using smartphones, some are using Apple. When you switch it on, it displays. Now that is the OS inside that smartphone. Now Android phones are there. Then Apple phone uses the other operating system. Okay, without that you cannot operate your mobile phone. So the mobile phone is also a computer. Okay, so for all that you need an OS. So here there are different types of operating systems are there. The user interacts with the machine via the OS. Here a software on the machine interacts with the hardware via the operating system. See, when you don't have operating system, even if you have a pen drive, a printer, you have connected to a computer, it will not work. In order to work all your external USB devices, you need an OS. OS intermediates between the hardware and the user. It is a coordinate. It coordinates between the user and the external peripheral devices. For example, input-output devices. In order to work with your computer, you need an OS. Okay. So it interacts with the user and the computer. Okay, the computer system comprises of a special set of hardware, software, user and data. Hardware consists of the components of computer like memory. Hardware, I told you when just 2 days back I explained you memory means what, processor means what, different types of storage devices you have learned, different types of input devices you have learned. In order to work all this, the OS is a must. Okay, the software may be of different kinds: application software and system software. Now I have also taught you what is an application software, what is a system software. See, operating system software means a machine. Minimum OS is required in order to work between the user and the computer. Application software means MS Office, Tally, so the PDF, they're all application softwares. So here, computer system may be a single standalone system or may consist of several interconnected systems. The user uses the application software to perform various tasks. For example, the user uses word processing software for document preparation, MS Word. We are using MS Word to prepare the documents. Okay. While using the application software, the user uses the storage of a computer to store a document on the hard disk, to execute a command on the CPU, to retrieve a document from the peripheral devices, or to print a document on printer. See, what are peripheral devices? All input-output devices are called as peripheral devices. Okay, you should not get confused. For using the hardware, there is a need for software that interacts between the hardware and the application software. Okay, operating system is the software that provides an interface between the computer hardware and the application programs or users. View of components of a computer system. See, first one is hardware. So once you have a hardware in your computer, you need an operating system. This is the OS. What OS? Different types of OS are there: Windows, Vista, Windows XP, Windows 10, etc. Utilities means some antivirus scan this zip files, all that comes under utilities. Application programs means MS Office, then Fox Pro, whatever the program softwares you want, that you are using that. Next is end user, means you are using. Next is definition of an OS. What is the now you know what is. Now you only can define an operating system. Now I have been teaching you, without the OS you can't work. Now you can design, now you can define what is an operating system. Okay, operating system is a system software that controls and coordinates the use of hardware among the different application software and users. OS intermediates between the user of computer and the computer hardware. The user gives a command and the OS translates the command into a form that the machine can understand and execute. OS has two main objectives. What are they? To make the computer system convenient and easy to use for the user. And the second one is to use the computer hardware in an efficient way by handling the details of the operation of the hardware. Okay, so it is very simple. So OS hides the working of the hardware from the user and makes it convenient for the user to use the machine. See, when you connect your printer or when you connect your mobile phone to the computer, you don't know how it is working. It hides the working of your peripheral devices. You can take a printout, or you can open your mobile phone in the system. You can see all the data in that, or you can also copy the photos which you have clicked from your mobile phones. See, all these beautiful things are done by the OS. It hides the working of all the applications. The application program used by the user requires the use of hardware during processing. Okay, some examples are display of applications user interface, loading a program into memory using IO devices. What is IO devices? Are input output devices. Input output devices, they are also called as peripheral devices. Allocating CPU to different processes during execution, and store or load data from hard disk. When using the machine, the user gives the command to perform the required actions to the OS. And the OS handles all the operational steps. The user is not bothered about how these actions will be performed. This is the job of OS. OS provides an interface to the application programs to interact with the hardware. The user need not get into the details of this interaction. At the other end, the different resources of computer hardware have to be managed and controlled. This includes managing the communication between different devices, controlling the sequence and execution of processes, allocating space on hard disk, providing error handling procedures, etc. OS supervises and manages the hardware of the computer. Functions of OS, functions of operating system. Now we will learn, now you know what is an hardware, what is a hardware, what is a software. So now you know what is OS. OS means operating system. Operating system is a large complex software consisting of several components. Each component of the operating system has its own set of defined inputs and outputs. Okay, different components of OS perform specific tasks to provide the overall functionality of the operating system. Main functions of the operating system are as follows. See, now these are the functions: process management, then memory management, file management, device management, protection and security, user interface or command interpreter. See, these are the different functions of an OS. You can see this: user interface, process management, protection and security, device management, file management, memory management. All this is done by OS inside your computer. Okay. Now let us study what is process management. The process management activities handled by the OS are: it control access to shared resources like file, memory, IO, and CPU. When I say IO, you should understand that it is input output. Okay, input output devices are also called as peripheral devices. Okay, next is control execution of applications. So what process management does is it controls execution of applications, creates, executes, and deletes a process. System process or user process. It resumes or cancels a process. Schedule a process. Then synchronization, communication, deadlock handling process. See, what is a process means? Process means a program in execution. See, sometimes you will use Word, sometimes you will use PPT. Whichever you are currently using, that comes in the, that is said to be a current activities will be in the process. A current program is in a process. Okay, that is called as a current program is a process. If you don't understand, don't worry. What is a process and all? It's a highly computer science only. It is in depth of computer science. Just know the functions of OS, means process management. Okay, how it works, don't bother. Next is memory management. Okay, the activities of memory management handled by OS are allocate memory, free memory, reallocate memory, program when used block is freed. See, memory management means whatever you store, you may delete the program, you may reallocate. See, all that allocation of memory, freeing of memory, reallocating memory, all this done by the memory management. So, memory management is very, very important. Whatever the memory you have in your hard disk has to be managed efficiently. Next is file management. What do you mean by file management? File management includes, like, as the file only, whatever you do in a computer, that becomes a file. Okay, so that file management task includes create and delete both files, directories, etc. Whatever you store, you are storing that file, right, by giving some name. So that is file. How, where you are storing in some directories. So file management is creation of file, deletion of files, creation of directories, access to files, allocates files, backup files, security of files. All that comes in file management. Okay, means creation of file, deletion of files, creation of directories, all that comes in file management. You can provide access to files, allocate space for files, keep backup of files, and secure of files, security of files, all that comes under file management. So all this happens inside the OS. OS does all this. Next is device management. What do you mean by device management? The device management tasks are handled by OS. Means open, close, write device drivers, communicate, control and monitor the device drivers. Device management means opening of a device, closing of a device, managing USBs, all that comes in device management. Okay, see, when you insert a pen drive or an external hard disk, suddenly you get one small pop-up message, right? It is opening, some dialogues it will show, na? So that is device management. So what is protection and security? OS protects the resources of system. User authentication, file attributes like read, write, encryption, backup of data are used by OS to provide basic protection. Okay. So next is user interface or command interpreter. Operating system provides an interface, user interface or command interpreter. OS provides an interface between the computer user and the computer hardware. The user interface is a set of commands or a graphical user interface via which the computer interacts with the application and the hardware. Okay, any hardware, suppose whatever the hardware you connect, suppose if you want to access that, you need an interface, otherwise you cannot access that. So that is user interface. Now you have studied the functions of operating system. Operating system means what it does. So the main functions are process management, memory management, file management, device management, protection and security, user interface or command interpreter. Okay, next is types of OS, different types of operating system. OS are classified into different types depending on their capability of processing. Okay, see, there are batch processing. So different types of OS are batch processing, single user, multi-user, time sharing, real time. Okay. Then what is batch processing? In this batch operating system, which analyzes your input and groups them into batches. All similar kinds of work is batched into, it is grouped into one batch. Okay, like that. Similar type of data. That is data into each batch is of similar characteristics, and then it performs operation on each individual batch. So here each user program which needed to execute was called a job. Okay, each user program is called as a job. A human operator watched over the queue with the ability to move some jobs to the front or back or kill a job which got hung or ran too long. Some users had higher priorities than others. See, whatever the program or similar type of each program here in batch processing. Each program is called as a job here. Similar type of programs are grouped into jobs. So one by one it will execute. Okay, all similar kind of jobs are executed one by one. Okay, so that is called as a batch processing. In terms of batch, it processes. Whereas in single task OS is for use by a single user for a standalone single computer for performing a single task. Operating for personal computers, PC or your desktop, they are all single user. Your mobile phones, they are all single user. For example, if the user is editing a document, then a document cannot be printed on the printer simultaneously. Single user OS are simple operating system designed to manage one task at a time. Okay. You can't edit and take simultaneously. Whether you edit or take a printout, any one single task at a time. Okay. For example, MS-DOS is an example of a single user operating system. MS-DOS is Microsoft Disk Operating System. See, most of them don't use MS-DOS because here this is not user-friendly disk operating system. This is a single user operating system. It requires the knowledge of commands. In order to execute, you need a set of commands. Okay. So MS-DOS is a single user operating system. Then what is multi-user OS? Multi-user OS is used in computer networks that allow same data and applications to be accessed by multiple users at the same time. The users can also communicate with each other. Multi-user means many users can access the same data. Okay, that is called as multi-user. For example, Linux, Unix, Windows 7 are all examples of multi-user operating system. Okay, single means only single person. Multi-user means many users can access the same data at the same time. Okay. Now, time sharing. Single user and multitasking OS allows execution of more than one task or process concurrently. That is called as time sharing. For this, the processor time is divided amongst different tasks. This division of time is also called as time sharing. Means here the whole program is divided into time. Each program is given a time. Okay, you can concurrently execute one by one. So here the processor switches rapidly between processes. For example, the user can listen to music on the computer while writing an article using a word processor software. Okay, so you can play the music and you can type the whole document. So that is a time sharing. The user can switch between the application and also transfer data between them. Windows 95 and all later versions of Windows are examples of multitasking. You can do multiple. You can type. You can keep on typing the document. You can also print the document like that. They are all time sharing. Okay. You can also listen to music. All that is time sharing. Next is multiprocessing OS. Multiprocessing OS have two or more processors for a single running process. Means multi means, as the name only tells, multi means many. Many processing means many processors, more than one processor in order to execute a single task. Processing takes place in parallel and is also called as a parallel processing. So each processor works on different parts of the same task or on two or more different tasks. Since execution takes place in parallel, they are used for high speed execution and to increase the power of computer. Linux, Unix and Windows 7 are examples of multi-processing OS. Means the more than two tasks is happening at the same time. So it is at the same time. Parallel processing means many processors can execute different tasks at the same time. Now, what is real-time operating system? Real-time operating system is which is happening at simultaneously. Now, internet is a real-time operating system. By sitting at home, you are doing business, you are ordering some things on the online. So that is all real-time operating system is which is happening at the same spot. So real-time OS are designed to respond to an event within a predetermined time. These OS are used to control processes. Processing is done within a time constraint. OS monitors the events that affect the execution of process and respond accordingly. They are used to respond to queries in areas like medical imaging system, industrial control systems, Linux OS, etc. They are all real-time OS. Okay. See, in real-time operating system, for example, internet is a real-time operating system. Okay. So embedded OS. Embedded OS is operating system is embedded in a device in the ROM. Okay, read-only memory. They are specific to a device and are less resource intensive. They are used in applications like microwaves, washing machine, traffic control systems, etc. I have yesterday's class. I explained you how washing machine, microwave ovens work. Even in they are all designed. A particular application is designed and embedded into a micro on the motherboard. Okay, so they are all specific, embedded. So we call it as embedded. Traffic control systems. हेलो हाँ मेरे डिपार्टमेंट में आ जाओ, मैं क्लास ले रही हूँ, आ जाओ, साइलेंटली आ जाओ. सेकंड वो मालूम है ना, मेरा डिपार्टमेंट कंप्यूटर साइंस डिपार्टमेंट, आ जाओ. ठीक है क्या? यस. ओके. So embedded system means washing machine, then microwaves, washing machine, they're all designed for a specific purpose only. You cannot use microwaves, ovens for washing clothes. Okay, washing machine cannot be used for cooking your food. So they are all designed in a specific manner for specific purpose only. Traffic control system. How traffic control system works? See, when you go to the traffic, see if there are three lights are there: red, blue, green. Red, green, and yellow. See, when red at one circle, it shows you, in one road it shows you red means stop. When it shows you yellow means get ready. When it shows you green means you can go. So it is designed in such a way that according to the traffic signals are designed. Okay, so they are all embedded OS. Okay, students, you have learned what is an operating system. You have learned functions of operating system. Now you have learned different types of OS. Okay, so you can refer for in detail. You can refer Alex Leon, then Raja Raman V for computer fundamentals. Okay, so now the last part is viruses. You already are familiar with virus. What is a virus? We learn what is a virus, different types of virus, infection and prevention. See, virus is nothing but it is a program which generates on itself. See, a computer is infected when a copy of the virus resides in the machine. Once the virus is loaded into the memory, it can run in background and start to replicate. It means it starts replicating on its own. So only it is called as virus. There are different types of viruses are there. Parasitic virus, worm virus, Trojan horse, macro, boot sector, hoaxes. These are all different types of, there are plenty of viruses are there. So how it is infected and how it can be cured. Okay, so these are different types of viruses. Now we have learned, now you know what is a virus means. It is a program which replicates on its own. So how we are getting through the internet also. So parasitic virus means, or file viruses are code fragments that reproduce by attaching themselves to executable files. When the user starts the infected program, the virus is launched first, and then in order to hide its presence, it triggers the original program to be opened. The parasitic virus acquires the same rights as the original program and thus is able to self-replicate and to release its payload. Next is worm. An internet worm, unlike a virus, does not infect other program files but uses computer networks and takes advantage of software bugs to replicate it. A worm scans the network for another system having one specific security hole, such as buffer overflow, and copies itself into new machine via SMT, FTP, HTTP means through the internet. SMT means simple mail transfer protocol, FT means file transfer protocol, HTTP means hypertext transfer protocol. This comes through the network and then continues the self-replication process, which makes your system slow. Okay, thus it has the ability to self-replicate incredibly quickly. Furthermore, the worm can release a payload such as scheduling a distributed denial of service DDoS attack toward a target system or network. Trojan horse, they are all different types. How it comes through the network only. A Trojan horse is a program which hides malicious code disguised in appealing shapes. It claims to do something cool or useful while actually provoking damages. Trojan horses are not designed to replicate automatically. Next is macro. Macro virus is one of the most common types of viruses for various reasons. It requires little skill to write. Many common application, word processing, spreadsheet, presentation, etc. make use of macros. And lastly, documents such as reports, slides, etc. are frequently exchanged between users. Macro viruses are self-replicating macros that can become active if the user opens, closes, or saves an infected document. However, recent versions of these micro-enabling applications display an alert concerning macro-virus risk and permit disabling of macro-execution. What is this? Boot sector is another virus. A boot sector virus infects computers by modifying the contents of the boot sector programs, replacing the legitimate contents with the infected version. This type of virus can only infect a machine if it is used to boot the system up. These viruses no longer represent a threat since operating systems now protect the boot sector. And floppy disks are actually unusable for storing modern applications. Now we are not using floppies. So hoaxes, so this is another type of virus. But simply messages containing false information, usually alarming, or instructions in pseudo-technical language, inducing unskilled people to perform actions which can provoke some damage. The user is often instigated to send this message to everyone in the address book. I tried. Okay, so these are different. Then infectious, many. So main vehicle for spreading viruses is internet. So how internet, they're all connected to, so from one computer to the other. Okay, so like that. So prevention, how do you prevent? By using the antivirus. So all that you can prevent the damages by using antiviruses. Okay, students, now you have learned viruses. I have covered the entire syllabus of skill development. Okay, right from the history of computers, generation of computers. Okay, then what you have learned, different types of computers, classification of computers. Okay, so if you have any doubts, you can. If you have any doubts, you can ask me now. Now I am okay. So I have completed the whole syllabus to you, and students, now I am posting a link to you. Okay, now this link, it will come in the chat box. Now you have to fill this Google form link to download the e-certificate. Okay, You have to fill this form once. Those who will not get the certificate today, fill the Google form next day. Okay. See, this Google form can only print 100 certificates per day. So keep trying. See, first 100 people will get, first 100 students will get their e-certificates. Okay, so any doubts? Yeah, do you have any doubts regarding my class? See, once again, I am sending this. So fill the Google form. So students have completed the entire computer fundamentals course. You have learned history of computer, generation of computers, definition of computers, classification of computers, how the how data processing inside a computer is done. All that in a very detailed form I have explained you. Then. A classification of software means what, hardware means what, input output devices, different types of input output devices I have explained you. If you have any doubts, you can ask me now. You have learned virus means what, different types of viruses. I have taught you operating system, different types of operating systems, functions of operating systems. All that in detail I have explained you. If you have any doubts, you can ask me now. Any doubts, students? Hope you have understood all 3 days which I have covered. I have finished the entire syllabus to you. I have not left any of the portions. हेलो हाँ नहीं नहीं उधर से आओ मेन गेट है ना उधर से आओ उधर से ओपन है ना वो सिक्योरिटी बैठा रहता है ना हुनसूर रोड से हाँ नहीं नहीं इधर इधर फर्स्ट वाला पहले वाला गेट ओपन है देखो हाँ ओपन है वो सिक्योरिटी ओपन है यार वो हमेशा खुला रहता है ओके स्टूडेंट्स हैव यू गॉट डू यू हैव एनी डाउट्स Okay, then I'll wind up my class and also browse my YouTube video. Go to youtube.com, gives Dr. Sumati Ramakrishna Gowda for computer fundamentals. You in detail I have explained with the diagrams, which is not possible here. So you please browse my video lectures also. Hope all of you have understood. Okay. Thank you so much, students. Shall I exit? If you have any doubts, you can ask me. I'll give you 5 more minutes before I exit. Okay, so hope no questions from your side. I'm not getting any questions from your side. Any doubts? Shall I wind up? Thank you. I'll wind up my class now.